This is Juno 8, question 7. A variable resistor whose resistance can take values from 0 to 10 k ohms is connected as a potential divider to a battery of 12 volts and negligible internal resistance. The two ends labelled A and B and the contacts labelled C. The output voltage V0 of the potential divider is between the terminals X and Y. The slider of the variable resistor is set to a position so that the resistance between B and C is 8 kilo ohms. Calculate the output voltage V0 between the terminals X and Y. And so what you can see here, we're just looking for V0, and we know that you have got a resistance between B and C of 8 kilo ohms. So that makes life quite easy because we know the total resistance is 10 kilo ohms. So if I write the little equation, V out is equal to V in R1 over R1 plus R2. We know that V in is 12 multiplied by R1 is 8 over the total resistance of the variable resistor is 10. And that's really what our sum becomes. And we get an answer then of 9.6 volts. The slider's now moved so that the output voltage is only 3.6 volts, so it's moved in this direction. Calculate the magnitude of the resistance between A and C. So A and C, so we're looking for the size of resistor 2. And so we'll just use the equation again. So our V out this time is going to be 3.6, and that's equal to V in is 12. We're looking for the size of resistor 2. And, well, then we don't know the size of resistor 1, so resistor 2 then. See, yeah, the output voltage. Okay. And then, no, we need to do R1 first of all, sorry. So we're going to do R1 over R1 plus R2, which is 10, total of 10. And when you rearrange all that, you get R2 comes out as 3 kilo ohms. And therefore, between A and C, R1 again. R1 is 3 kilo ohms, and that's between X and Y, which is over here somewhere. So we're looking for this, and so you take it away from 10. So is it equal to 10 minus 3, which gives you 7 kilo ohms. The slider contact is now set so that the resistance between A and C is equal to the resistance between C and B. So the resistance of 5 kilo ohms each. A load resistor of resistance 15 kilo ohms is now connected between terminals X and Y. Calculate the difference of the voltages between X and Y when the load resistor is present and when it is removed. So if I just draw that out, I'm just going to draw it over the side here. So these are your two, this is a variable resistor split into two 5s. And if you have got an initial voltage of 12 volts, then when there's no resistance present, no external resistance present, they're going to get 6 volts each. But whenever you connect then the 5 ohm to 15, I should say 15 kilo ohms and 5 kilo ohms, then it's going to be a different story. And so we need to find our total resistance, first of all, of this parallel bit, and I'll do it in red. So that's a product over the sum. And that gives you 3.75 kilo ohms. And then you can just use your equation again, V out equals, so V out equals V in is 12. R1 is this bit here, so it's 3.75. And then divided by the total resistance is 3.75 plus 5, which is 8.75. And that gives you an answer of 5.14 volts. And so we have to take that away from 6. So the difference in the values is equal to 6 minus 5.14. And that gives you 0.86 or 0.85, 0.86 if we use that rounded up. So 0.86 volts. Next part of the question, answer 1 2 by ticking the appropriate boxes. When the load resistor between X and Y is decreased in magnitude, the difference in voltage calculated would be. So we have a wee look at this. If that was smaller, then you would have a smaller total resistance here. And the difference in smaller total resistance, smaller total output voltage, and therefore the difference between that and that would be greater, and so it would increase. the current drawn from the battery. So if you have a smaller resistance in the whole circuit, the whole resistance is down, and therefore the current flowing through it is going to be down as well, and so it's going to decrease. Sorry, it's going to increase, I mean, of course, it's going to increase. Right, AS1 June 09.